Hi everyone, this is example 2 from chapter 18 in your student packet. A composition teacher wishes to see whether a new grammar program will reduce the number of grammatical errors her students make when writing a 2-page essay. The data are shown below. Using an alpha of 0.05, can it be concluded that the number of errors has been reduced using the new program? So this is a paired t-test because the same students are in both samples. This is a before and after scenario. So let's put the errors that were made before the new grammar program into L1 and the errors after the new grammar program into L2. And then we'll let L3 equal L1 minus L2. And when you put that in your calculator, you'll get 3, 3, negative 1, 2, 2, and 0 for L3. So because this is a paired t-test, let me get my pen back here, a paired t-test, we're going to run a regular t-test on L3. So our null and alternative hypothesis for paired t-tests use mu sub d because we're looking for the mean of the differences. And here we want to find out if this new program makes a difference. So that would mean that the null hypothesis is that there is no difference between the number of errors made. And the alternative hypothesis will reduce the errors, which means that the mu sub d, if we do L1 minus L2, if we reduce the errors, that means L2 will be less than L1, meaning that the difference will be greater than 0. Let me say that again. We're reducing the errors. Where is it shown? We'll reduce the errors, which means that L1 will be greater than L2. The errors before will be more than the errors after. So if you take a larger number minus a smaller number, you will get a value that's greater than 0. So be careful, you can't just use the wording in the problem. You'll really have to think through how you're doing the subtraction. So then we're going to go to stat, tests, and we're choosing a regular t-test. We have data. The mu sub 0 is going to be 0. Our list is L3. The frequency is 1. And we are looking to see if their mu is greater than 0. And when we calculate this, we get a test statistic of t equal to 2.236 and a p-value equal to 0.0378. So when we compare our p-value to the alpha level of 0.05, it is less than that. So since the p-value is less than alpha equal to 0.05, we reject the null hypothesis and conclude that there is enough evidence to suggest that the new program is reducing errors in their 2-page essays.